Organic molecules are used by organisms to acquire energy and grow biomass. There are four major groups of organic molecules. The carbohydrates, think starches and sugars. Lipids, like fats and oils. Proteins, which make up most of our muscle, hair, nails. And nucleic acids, a special group of organic molecules that compose our genetic material. Organic molecules have a carbon skeleton. Now, what do we mean by that? We'll take a look at glucose here, and you'll see that what we mean by a carbon skeleton, a whole bunch of carbons linked to each other, making the backbone of this molecule. So this is something that all organic molecules have in common. Now, there are other elements typical to organic molecules, elements like oxygen you'll see frequently, and hydrogen as well. In fact, there's 6 common elements that make up biomass, most of the biomass in organic molecules. Those are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And you can remember these 6 easily by thinking of the letters in yellow there as schnapps. Okay, organic molecules fall into one of 2 categories. They will either be hydrophilic or hydrophobic. Hydrophilic means water-loving. These are compounds that are polar and therefore water-soluble. They dissolve in water. So let's take a look at this. Consider a sugar cube made up of a whole bunch of glucose molecules here beside each other. Now remember that oxygen is highly electronegative, so all of these carbon to oxygen bonds you see here, I've just outlined a few of them, are not sharing their electrons equally. Oxygen has electrons around it most of the time. Thus, these are polar bonds. All of these bonds represent a little bit of polarity, unequal charge on either side of the bond. Now remember that water itself is a polar molecule with that negative charge around oxygen and the positive charge around hydrogens. So when we dump that sugar cube into water, water will break apart those glucose molecules because of the interaction of the polar sides of the water molecule with those polar bonds. So anytime a molecule is polar, it will most likely be soluble in water. We call that hydrophilic. Hydrophobic is the opposite case, where we have molecules that are non-soluble because they're non-polar. Hydrophobic literally means water-fearing. For example, many of the fatty acids in lipids are just straight carbon and hydrogen chains, very, very long chains of just carbon and hydrogen. Now, carbon and hydrogen have roughly the same electronegativity, so these bonds are not polar. So when polar water comes along, those two do not mix. Lipids are a good example of non-polar or hydrophobic compounds that will not be soluble in water. And you know this if you've ever seen oil collect on the surface of water. Okay, so most of these organic molecules are made up of small repeating molecules called monomers. Monomers are the basic subunits of organic molecules. They repeat over and over again to form polymers. They're bonded together covalently, and when we have a chain of monomers in a row, they're called polymers. So, for example, consider these 3 monomers here. These are all molecules that are roughly similar in their structure, and they will be bonded together in a reaction we'll take a look at in a moment to create a polymer. So here you see a chain of those repeating subunits, monomers, making one complete polymer. And large polymers are called macromolecules, and those are the carbohydrates, lipids, proteins, and nucleic acids that we'll be talking about later. Okay, so let's make a polymer. Making a polymer, whether it's any of those 4 groups of organic molecules, involves the same reaction called a dehydration reaction. So take a look at these 2 monomers. Now, if you recall, monomers typically have a lot of OH groups hanging off the sides of them. These are hydroxyl groups, so recall our glucose molecule here, and you see a few of those hydroxyl groups off to the side. So what happens in a dehydration reaction is a hydroxyl group from one monomer combines with just the hydrogen from the hydroxyl group of the other monomer to form water, H2O. And the leftover oxygen there then makes a covalent bond with the other monomer. and therefore we have a dehydration reaction because of the water that's formed. So you know dehydration means to pull the water out, and effectively that's what we've done, is pull the water out of these two monomers and join them together. To break a polymer involves a reaction called hydrolysis, which is just effectively the reverse of a dehydration reaction. If we examine that word hydrolysis and break it in half, we see that hydro means water and lysis means to cut in half, which is what we're going to do. So that water molecule down there will divide up into its hydroxyl group and hydrogen, and then that will sever that bond between the oxygen and the monomer and go back to the individual monomer subunits, just exactly the reverse of the dehydration reaction.